Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about segmentation in detail. So I request everyone to watch the complete video for better understanding. We have two types of memory allocation. One is the contiguous memory allocation and non-contiguous memory allocation. In contiguous memory allocation, we have fixed size partitioning and another one is variable size partitioning. In non-contiguous memory allocation, we have paging and segmentation. I have discussed about paging, multi-level paging, page table, TLB, all these concepts I have discussed in detail for you. I hope you have watched those videos. If you did not watch those videos or if you don't know those concepts, I request you to go back and watch those videos and come back to this video. In this video, I want to discuss about segmentation, advantages of segmentation and disadvantages of segmentation in detail. Now, first let me discuss what are the drawbacks of paging. Suppose let's take that user has written 1.c program. Okay, in that program, there is a user defined function called add. Okay, now this add function consists of some 100 lines. Okay, if we go for the paging, we know that a process is logically divided into pages and main memory is divided into frames, and the page size will be equal to frame size. Is it clear? Now if we go for the paging, let's consider that this 100 lines of the code is divided into two pages such as page 1 and then page 2. The page 1 consists of first 50 lines and page 2 consists of another 50 lines. Let's consider that in main memory we have only one frame is freely available. Is it clear? Let's consider that it is frame number 0. Now, whenever CPU want to execute this instruction, it will ask for the particular page. Let's consider that CPU has requested for the page number 1. Now, whether the page number 1 is currently available in the main memory, it is not available. Then what we will say, it is a page fault. Then operating system will take control and load the page number 1 from the secondary memory to the main memory. This process we will call it as swap-in process, and the entire thing like operating system take control and then swap-in process and again context switching will call it as page fault service time. Is it clear? Are you able to understand? So page number 1 is loaded in the main memory frame number 0. Now the CPU will execute the instructions. Now when CPU requests for the page number 2, because after executing the 50 lines of the code, you have to execute the remaining 50 lines of the code. Am I right? So now CPU will request for the page number 2. Now the page number 2 is also not available in the main memory. So again page fault will occur, and then let's consider that using the page replacement strategy, you have identified the page number 1 is the victim page, so you will remove the page number 1 and load the page number 2. So even the add function is a single module. In paging, it is divided into two pages. Once the page number 1 is executing, page number 2 is not available. When page number 2 is executing, page number 1 is not available in the main memory. And another drawback of the paging is the internal fragmentation. Let me discuss with a simple example. Let's consider that process size is 4.2 KB. Okay, and page size is 1 KB. Now, how many pages are required if you have a process size of 4.2 KB and page size is 1 KB? You need 5 pages. Am I right or wrong? Let me divide that one. You have a process, okay, of 4.2 KB. Now, page number 0 will have first 1 KB and then page number 1 will have another 1 KB. Page number 2 will have another 1 KB. Page number 3 will have another 1 KB. So you have 4 KB out of 4.2 KB. So page number 4 will have 0.2 KB. Now even the page size is 1 KB. Are you able to understand? We are using only 0.2 KB of the particular page. So 0.8 page, 0.8 KB is free, but however we cannot use this space. So this one we will call it as an internal fragmentation. So even the page size is equal to frame size, there is a possibility of internal fragmentation in paging. Is it clear? So to overcome this problem, that researchers or the developers have introduced the concept called segmentation. In segmentation, the process and main memory is logically divided into segments. Okay, are you able to understand? In paging, the main memory is divided into frames and process is divided into pages. But when it comes to the segmentation, the main memory and secondary memory is divided into segments. Okay, and remember one important point: the page size and frame size is fixed, but when it comes to the segments, the size of each segment is variable. So I can say that it is variable partition. Are you able to understand? Now let me discuss with a simple example for you. Let's take that you have a secondary memory. In the secondary memory, let's take that you have a process P1 which consists of 5 modules. Now what you have done, you have divided into 5 segments. Okay, this is segment number 0, segment number 1, segment number 2, segment number 3, segment number 4. And remember one thing, the size of each segment may be same or different. Is it clear? Are you able to understand? Usually it will be different only. And then main memory, some part of the main memory will consist of operating system. Is it clear? Now let's consider that the segment 0 is 1 KB. Then 1 KB of space will be allocated for the segment S0. Let's take that there is some other segment of a particular process, some other process, okay, is using of consists of 0.5 KB. Let's consider that. Okay, then you have a segment S1 of this process P1. Let's consider it is 2 KB. Then that will be allocated here. Then let's take that another segment is available of a particular process which is of 4 KB. Is it clear? Now let's take that your free space is some 8 KB. Now your segment S4 of process P1 has been allocated of 8 KB. So what I can say is that it will be a variable partitioning based on the size of the segment. The particular amount of main memory will be allocated. Is it clear? So I can say that the process and the main memory is divided into segments. Is it clear? Now we will discuss few important points related to the segmentation. You know that CPU will always generate the logical address. The logical address will consist of segment number and segment offset. When it comes to the paging, it will consist of page number and page offset. When it comes to the segmentation, it will consist of segment number and segment offset. Now we will have a segment table because the logical address will be converted to physical address with the help of memory management unit. So the memory management unit will use the segment table. Now what is the segment table will consist of? Now segment table will consist of for each process. Each process will have its own segment table and the number of entries in the segment table will depend on number of segments. Let's take that here we have 5 segments, then it will have 5 entries and each entry will consist of 2 important things. One is the base and then another one is limit. What is the meaning of this one is, let's take that segment number 0. Segment number 0 is starting address is, let's take the 1000. Okay, is it clear? Then you have the size of the segment. Each segment will have its own size. Am I right or wrong? Let's take that the segment size is, let's consider that it is 200 bytes. Are you able to understand it or not? So the base will tell you the starting address and the size or limit will tell you what is the size of the segment and what is the end address also. Is it clear? Are you able to understand? So if let's consider that segment S0 is 200 bytes and its starting address is 1000, then ending address will be 199. So with the help of the base address and size, you will come to know the starting address and the end address of the particular segment. Is it clear? Are you able to understand? So CPU will generate the segment number and offset. So it will look at the segment table and remember one thing, where the segment will be table will be stored. the segment table will be stored in one of the segment of the main memory. Are you able to understand? Even in the paging, the page table will be stored in one of the frame of main memory. Now, whenever CPU generates the logical address of a particular process, it should know where the segment table is also stored in main memory. Am I right? Let's consider it does not know where the particular segment is stored, but it should know where the segment table is stored in the main memory. How it will come to know is that one register will consist of segment table base register. Suppose let's take that this entire segment table is stored in some 9000 address location. So the register will consist of 9000 location. So whenever CPU generates the logical address, first it will look at this register and fetch the segment table. Okay, once it got the segment table, it will add the segment offset for it and go to the particular segment, and then it will verify whether the offset is less than the limit or not. Let's consider that CPU has generated the logical address consists of segment number and then offset as some 150. Is it clear? Meaning is that it is requesting for 150th byte in segment S0. Now, what is the limit or what is the size of the segment S0 is 200 byte. So, if you have a segment of 200 bytes, will you have 150 byte? Yes, it is there. So, that is what we are checking. If offset is less than the limit, then we will go to the main memory and access the information. If it is wrong, meaning is that let's consider that CPU has generated the logical address consists of segment number as S0 and offset is 400. Now, if your segment size is 200 bytes, how can you give a 400 byte? It is not possible. So then a trap will be generated. Are you able to understand? If it is less than, offset is less than the limit, then it will add the offset to the segment base address and it will go to the particular byte and access the information from the main memory. So this is overall information about the segmentation. Now let me discuss the advantages and disadvantages of segmentation. One is that segmentation will remove the internal fragmentation. So first let me discuss about the advantages. One is the advantage is that segmentation will remove the internal fragmentation concept. Okay, but there are few disadvantages with the segmentation. Now let me discuss the disadvantage. One is the external fragmentation. This is the major drawback of the segmentation. Why there will be an external fragmentation? Let me discuss for you. Let's consider that at a particular instant segment S1 has been removed and this one is also free. Is it clear? Are you able to understand? Let's consider the 2.5 KB is free here. Are you able to understand? Somewhere 2.5 KB is free available here. And let's consider that at particular instant of time, you have 1.5 KB free here. So entire remaining thing is full. So you have 2.5 KB here and 1.5 KB here where they are not contiguous. Is it clear? Now you got a segment S5 whose size is 4 KB. Even you have a total free space of 4 KB, there is a request from a particular process of segment size is 4 KB. We cannot allocate that space. Are you able to understand? So this scenario we will call it as external fragmentation. So segmentation will overcome the internal fragmentation problem. However, it will cause the external fragmentation. I hope you have understood about the segmentation. However, now we are not using the segmentation. In the next video, I will discuss about segmentation with paging. Thank you for watching the complete video. If you still have any doubts related to the segmentation, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Have a nice day.